Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Asrul with matrix number MA22004. Today I would like to present about how to calculate the average velocity of the auto gate. First and foremost, we need to have the diagram, which is we have a triangular shape diagram, which is we have point O, point B, and point A. The distance from point O to B and point B to A is the same, which is 2.0 meter. And first and foremost, to calculate the average velocity, we need to have the omega. And to have that omega, we need to have the max piston speed. We use internet to have the piston speed, which is 0.029 meter per second. We assume that max piston speed is 0.029 meter per second. And then to calculate the omega OB, we just use the formula of V equal to R omega, which is V 0.029, and also the distance, which is 2. And we get the omega OB equivalent to 0.0145. Omega OB, for your information, omega OB and omega BA is the same answer. So we can assume that omega BA also will be 0.0145. So that we need to calculate the VB. To calculate VB, we can use the formula of VO plus VB respect to O. As we know, VO located at point O, which is static point, and we know that static point V equal to 0. So we can just use the formula of omega BO times by ROB, and we can have the omega OB, which is 0.0145 K, times by distance of OB, which is 2 sin delta J plus 2 cos delta I. And we can distribute the VB into I component and J component, which is respected to X is I and respected to Y is J, which is we get the final answer for VB is negative 0.029 sin delta I plus 0.029 cos delta J. Then we need to calculate the average velocity. We need to have VA, which is, to calculate VA, we use the formula of VA equivalent VB plus VA respected to B. For VA, as we can see, VA just directed in x-axis, so we just use VAXI. So we do not have to use the VAYJ. And we put the VB amount that we already got, and plus with VAB, which is omega AB times by negative 2 cos delta I plus 2 sin delta J, which is both are the distance from B to A respected. And we got the answer of negative 0.029 sin delta I plus 0.029 cos delta J minus 2 cos delta omega ABJ minus 2 sin delta omega ABI. And we can distribute it into I component and J component. For I component, we have the VAXI equal to negative 0.029 sin delta I minus 2 sin delta omega AB. And as we know, omega AB is equivalent to omega OB, which is 0.0145. So we include that in the calculation, and we got the final answer of VA is negative 0.058 sin delta. For J component, as we can see that we have no J component, so we can put is 0 equal to 0.029 cos delta J minus 2 cos delta omega AB. And when we put the number of omega AB, which is 0.0145, we can get the answer of 0. So for J component, we can sure that it is no J force. So the direction for VA just in x-axis. For negative 0.058 sin delta, it is for when the gate is opening. The VA average velocity for VA when the gate is opening. For when it's closing, it's moving towards another direction, which is positive. We just change the sign and it will become 0.058 sin delta when it closes. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam bin Ahmad Faizal and my ID number is MA22002 and today I'm going to talk about vector solution. So first, I draw the FBD and state and show the direction of velocity and omega. And then I find the omega OB by using the value of piston max speed for velocity in equation of V equals to R omega, and then I find the VA by using the recent equation that Eman has stated, which is 0.058 sine theta, and the theta is 30. So I get the value of VA, which is 0.029, and then I find VB by stating that the counterclockwise direction is positive, and I studied is VO plus VB from O, and I get the VB is negative 0.0145 I plus 0.0251 J. And then I find the VA in vector form, uh, which is negative 0.029 I by using equation VB plus VA from B. And then I find the VA from B by using equation VA minus VB, and I get negative 0.0145 I minus 0.0251 J in vector form. And then I use the magnitude vector formula to get the magnitude value of VA from B, which is 0.03 meter per second. And then I divide it by 2 to get the velocity of midpoint in panel AB, which is 0.015 meter per second.
Assalamualaikum and hi, my name is Daniel Akmal bin Muhammad Alwi, matrix number MA22005, and today I'm going to explain for the scalar solution when given theta 30 degree and finding the velocity of the midpoint for panel AB. So we have here the diagram for the automated moving gate and the full body diagram. As you can see, theta is given 30 degree, and both of the panel for OB and BA is the same length. So supposedly the the degree for the OAB is 30 degree also. And then we have our VB 90 degree and VAB also 90 degree. So based on the average velocity at point A, we have VA equal with negative 0.058 sine theta. So we're just gonna substitute theta with 30 degree. So by using the sine rule, we have VAB, VB, and VA, which is 30 degree, 60 degree, and 90 degree. So by using sine rule, so we have VAB over sine 60, which is the opposite degree for the VAB facing it, equal with VA over sine 90 degree. So we can find VAB 0.029, which is VA when you substitute the equation inside the average velocity at point A, 0.029 over sine 90 degree times with sine 60, and we got the answer is 0.03 meter per second. So when we are finding the midpoint of panel AB, so I indicate the midpoint at the panel AB as C, so we can find VC. So the direction of VC is similar to the direction of VAB. So I can conclude that VC is equal with VA over B over 2. This is to find the velocity of midpoint panel AB. And then we have the answer VC equal with 0.015 meter per second. And that is the final answer for the velocity of midpoint of panel AB using scalar solution. Thank you very much.
Hello everyone, my name is Kishore Pillai Analakir Ravindran and my metric ID is MA21111. So today I'm going to present about the IC method. So as you see, this is our free body diagram and this is how we find the IC of this diagram. So this is the direction of the VB and this is the direction of VA. As you see, this angle is 120 degree, so this angle should be at 60. So when it comes to 60 in triangle rules, when one angle is 60, so every angle will be 60 because total angle triangle angles of triangles is 180 degree. And to find our R RBIC, so it's easy because this is the same length, it is same length, so it is 2 meters. So in order to find VB, we use omega R formula. V equals to omega R. So VOB times by RBIC. So this is answer for VB, which is 0.029 meter per second. So which is, and for VA, as the direction going on the left hand side, it should be in negative. So you come the same answer but in negative, which is negative 0.029 meter. So in order to find the midpoint velocity of AB, we have to find the AB first. So we use the cosine rule, which is VAB equals to 0.029 plus 0.029 minus 2 times by negative 0.029 times 0.029 and cos 120. So which means is we use the information, the lines between AB, and we got the answer as 0.0292. So in order to find the midpoint velocity of AB, we have to divide 2. So when we divided it into 2, it becomes 0.014 meter per second. So this is the midpoint velocity of AB. So as we see, we use the formula of V equals to R omega in order to find all the velocities in here. So thank you. That's all from me.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin Isma Faridi and my ID matrix is MA22003, and I'm gonna be talking about the program for our project. So in this project I use Python to construct our program. As you can see on the left side, I use um about 64 lines of coding, and uh, if you can see on the line number 24, that's where the calculation and the formula that I used starts, and I follow the Scala method that my friend have been done. So I just translated from the Scala method that he uses into the coding. And for the omega, I use omega OB and omega AB. I uses V equals to omega R. Okay, then after that, if you run this code, you can obtain many degree, which is 0, 10, 20, until 19. And you also will get graph, which can be seen on the middle of the screen. The graph says that on the body of OB, which is omega OB, we can see it's all positive. This due to the rotation of the body is anti-clockwise. and the opposite, which is AB, is direction is clockwise, which is negative. So that's it. Thank you.